Hi, everybody. My name is Walter Chinsky, and I would like to speak today about the most famous equation in finance, the Black Scholes equation. I would like to present the alternative calculation of the Black Scholes model and discuss the meaning of Nd1 and Nd2. You will find many explanations what Nd1 and Nd2 means. You see here a couple of possible explanations on this slide. I am not going to analyze these different interpretations of Nd1 and Nd2. I will try to explain Nd1 and Nd2 as z-scores of two populations with different means. I was very excited when I derived this interpretation, and I am sure you will feel the same excitement as well when I share with you my thoughts. So let's start with a brief explanation of the z-score. Normal distribution, as shown here on this graphic, is a probability distribution that is symmetric about the mean, showing the data near the mean are more frequent in occurrence than data far from the mean. In the graphical form, the normal distribution appears as a bell curve. You can see that around one standard deviation is also the z-score, about from -1 to 1, to +1, we have 68% probability that event will occur in this area, so quite close to the mean. If you take two standard deviations, -2 plus and +2 standard deviations, you have the probability of 95%. And if you go three standard deviation minus and 3 standard deviation plus, in principle, you have more than 99% of the probability that the event will occur. So we have this is what I am showing here is the standard normal distribution with the mean of 0 and standard deviation of 1. But you can transform any normal distribution into the standard distributions. And maybe, I don't know whether you remember, but in the Stone Age, when I was learning statistics, we didn't have Excel, we didn't have any personal computers, so we had to use the standard tables. So if you wanted to find out what is the probability of event will occur and any normal distribution, not the standard, you had to convert this into the standard using so-called z-score, and then you looked into the table, which were always only for the standard normal distributions prepared. Otherwise, you would have to prepare a distribution from unlimited or too many to be able to prepare, but it was not necessary because with the z-score, with the calculation of z-score, you could transform any normal distribution into the standard normal distribution. And how you had to do it? Z-score is defined as the as the event, what the x variable which represents something in your distribution. In our case, it will represent spot price. Then minus mean, which you calculated for your distribution, divided by standard deviation of your distribution, and then you have your z-score. And the z-score tells you how far away you are from the mean. But you have to keep in mind you have two different interpretations of z-score. One, as is shown here, as the z-score as the how far away you are from the mean, or the second interpretation, which is important for us when we analyze the Black-Scholes model. We have to keep in mind that in Black-Scholes model, z-score applies in the sense of a cumulative z-score. Z-score gives the probability that the standard normal random variable is lower than z. So you are going from the left of the distribution to your event, and you have all from the left up to the z-score, which is smaller, probability for events which are smaller than the z-score. But when we look, for example, for prices of the call options, so the probability of the call option is the option will be in the money. So we are not looking for the market prices which are lower than strike price, but we are looking for the prices, the probability that the prices are higher than the strike price. Therefore, we need to calculate I1 minus the score, minus the z-score. I have prepared here one graphing problem about the normal distribution, which shows you also how you calculate the z-score. And I also try to interpret or already this graphing in the sense of our Black-Scholes model. So in our Black-Scholes model, which you will see in a moment, we calculate call premium for the when the spot price is 25 and the strike price is 25, volatility is 40%, and based on this information, we are calculated the z-score, or minus z-score. So when you see now in black, you see the probability that the prices are lower than the strike price. But what is really what we are interested in our Black-Scholes model is that the prices are higher than the strike price, and this is shown here in blue. And according to what our models requires, we have calculated here the Nd1 probability, which in this model amounted to 56%. You can also look at the chart of the cumulative probability, and also here in the sense of the Black-Scholes model, how Nd1 as the z-score is calculated, or in the sense of 1 minus z-score in order to show the prices which are higher than strike price. So you see here, according to this distribution, the probability that price of the financial asset will be higher than 124 is almost 100%. That it is higher than 18 18.52 is higher than 80%, and that the probability that the model will, that the strike price is in the money. Now you will see very important thing where you can recognize that we are talking about two different probabilities. One probability according to Nd1 calculation, and now you see that the strike price is in the money from 59.6, but if you look at the graphic showing the Nd2 probability for the strike price to be in the money, because it is a different different population with different mean. The probability is, for example, here around 40% when the strike price is coming into the money. So this was the interpretation of the z-score. I tried to show you graphically the difference between Nd1 and Nd2, and now we are coming to the model, Black Scholes model, and I am showing you the difference between my calculation and the calculation according to the Black Scholes formula. The general formula called premium is spot price, discounted spot price, times probability, Nd1 in this sense, minus strike price, discounted strike price, times probability, calculated according to Nd2, is the same in the both models. It's no difference. But how we arrive at Nd1 and Nd2, it is a different story. This you have the probability or the z-scores. I say z-scores. In Black Scholes model, they are called D1 and D2. And now how I do this at the time when we have the Excel, we don't need any any standard table for cumulative distribution. We do everything with the statistical functions which are offered by Excel or Google Sheets. So using what our computer provides us, we just start with a definition of mean 1, corresponded to D1, and mean 2, it corresponds to D2. And I will show you in a moment also how 1 can be transformed in D1, or on the mean 2 can be transformed into D2. But just to prove the case that we are talking about the same stuff. And then in order to find Nd1, I take the formula 1 minus log normal distribution function from Excel, where I have to enter the strike price, mean, already defined, volatility, and since I want to have this as the cumulative calculation, I have to say true. With this information, now I am trying to prove what I said before, that when we have the z-score, when the z-score is defined as the x variable minus u mean divided by standard deviation. So what is here? X is logarithmus of the strike price minus mean, and this minus logarithmus of the spot at the spot price minus 0.5 times volatility square minus interest plus dividend multiplied with time, and all the stuff is now divided by sigma times time squared. If I take this equation and multiply this with minus, and according to the logarithm law, I don't need to write logarithm 1 minus logarithm 2. I can take them into the divide one by the other. So after I multiplied this equation with minus 1, I have now logarithm spot is positive, spot price, divided by strike price, plus, since I multiplied everything with minus, I have the plus 0.5 times volatility square plus interest minus dividend, everything multiplied with time and divided by sigma times square root of time. And what it is, this what we have calculated is simply D1. So we are exactly at D1 what Black Scholes uses in their model. What we only change, but instead of calculating D1, since we have the Excel functions available on our desk, it's much easier for us to work according to what Excel is asking for, and it wants to know from us the mean of our distribution and the standard deviation, and wants to know from which X value, in this case strike price, we are talking about. And when with this information we can calculate option price immediately. You can see on this slide, in green, we have the spot price of 25, strike price of 25, volatility of 40%, time, I took 1 year, dividend 5%, and risk-free rate is 4%. Out of this information, I can now calculate the mean of this distribution for according to Nd1 rules, and the mean of the second distribution according to Nd2 rules. And now with this information, I can very simply calculate, create a model and find out that with these numbers, our Black Scholes model is telling me that with probability of 50, that is Nd1, with 56.95%, the prices will be higher than strike price, and multiplied with the with discounted strike price, we have the value of 30.5. It is in principle our gain. And now, according to Nd2, with a probability of 41%, strike price multiplied with 41%, discounted with according to agreed rules, we have 9.8, and the difference is 3.6703. It is how much we would pay for the premium, and you can see it is exactly the same number if I use the Black Scholes calculation. In the last chart, what I want to show is only the formulas which I use. So if you stop the video and just check in case if you would like to recreate the model on your computer. So I hope you like it. I hope that you learned something, and thank you for listening.